Good morning, good afternoon, or good evening, whatever time you're watching this educational video again. We will be discussing now about conduction charging. And we're done with triboelectric charging. Now, this time, we will have another type of um, contact electrification, which is about conduction. Charging methods we will review. We have the two types, contact electrification and the non-contact electrification. This video will just focus on contact charging, or we call it conduction. So we will explore more about conduction, or in other books, they call it contact charging, charging by contact. Conduction. It is when a charged object touches a neutral one. Please take note. Conduction is happening once you will have a charged object and it touches directly, or there is a contact with a neutral one. So you can create a charge, or you can charge an object through conduction when you have a charged object and then you touch it to a neutral one. So how does charging occurs via this method? Of course, during our discussion about triboelectric charging, we had this example about a cloth or a wool rub to a plastic ruler, and then electrons move from the wool to the plastic ruler. So we will use the plastic ruler now. Since the electrons move from wool to plastic ruler, then the ruler will gain more electrons and becoming negatively charged. So that ruler is now our charge object. Remember, by definition, conduction is when a charged object is touched with a neutral one. So let's take an example. Ruler is our charged object. It's negatively charged because during triboelectric charging, the electrons from the wool transfer to the ruler, becoming more, more negative. So it's a negatively charged object. It's a charged object. There is an existence of charge already. And we will gonna touch this charged object to a neutral object. That's a rabbit fur cloth. If you could still recall, in the triboelectric series, which one will donate electron, which one will accept the electron? It depends upon the affinity, electron affinity between these two objects, plastic ruler and a rabbit fur. Let's try to find out later. When we say neutral object, it means again and again, electrons and protons, the same number. So that's neutral. There's no such thing as a neutral charge, so let's avoid saying that one. Neutral charge is not really acceptable in physics. When we say neutral, it has the same number of electrons and protons, and they cancel out because they have different signs, positive and negative, and they have the same magnitude, so they cancel out. Zero charge. And the, there are two charge particles only, or charge phenomenon, which are positively charged object and then a negatively charged object. Avoid using neutral charge. Okay. In this scenario, our charged object is the negatively charged plastic ruler, and then we have the neutral object, which is having the same number of protons and electrons, rabbit fur. What will gonna happen if we will gonna touch the ruler directly? There is a contact directly to the rabbit fur. Remember, neutral, rabbit fur, and then charged object is our ruler. That's what will gonna happen. There is a contact, and this charged object has more number of electrons, and the neutral object will have that same number of protons and electrons. In my illustration, I just did it that way, but to let you visualize how conduction happens. Okay. Now, upon contact via conduction, this is what will gonna happen. It creates the electric potential difference, or we call it voltage. Electric potential difference, that's another term, which is long term for voltage. The electrons move from high to low in terms of electron concentration. If you could still recall, in our triboelectric charging, electrons move from high concentration, many electrons, to the area with low concentration of electrons. So in that case, in a triboelectric series, since the object, okay, let's not talk about that one. I'm very sorry. Let's proceed. And the movement of electrons is from the charged object because it has many electrons. The concentration there is high. So it will move from high concentration of electrons. And then when we say high concentration of electrons, it is like corresponds to a low voltage. When you have many electrons, the voltage of that object will become lower. So that is why, according to this slide, if not about electron concentration, electron will move from low voltage potential or low voltage to a higher voltage. Just the same thing like what I have said in my previous um, video about triboelectric charging or friction charging. Again, it will move from high concentration of electrons to low concentration of electrons, or if you concentrate on the voltage or the electric potential difference, it will move from low voltage to high voltage. Low voltage, when there will be many electrons there, it will have a low voltage, while if there is lesser electrons in a material, the voltage there is high. Please remember that concept. So what will going to happen upon contact? During conduction, electrons will move from high concentration to lower concentration, or from low voltage to high voltage. Okay, until both materials will have the same electrical potential difference, meaning both will have the same voltage. And once these materials will have the same voltage because electrons move from higher concentration to lower concentration, until they become their voltages will have the same uh, volts. The electrons there will stop moving or will stop transferring because they have the same voltage or they have the same electrical potential difference. If there will be equal voltages between these two materials in conduction, the electrons will stop moving. And please take note, some students will think that when voltage is the same between two objects, there will be like the same number of electrons between the charge ruler and the rabbit fur. It does not have to be like that. Okay. We will have a separate lesson for that voltage in our next chapter, but it doesn't mean that they have the same number of electrons. It's just that electrons from higher concentration transferred to the object with lower concentration, and they keep on exchanging electrons until both objects will have the same potential difference, the same force pushing these electrons. So the electrons will now stop moving once it is achieved. The equilibrium is achieved. So it doesn't mean that there is equal number of protons or electrons or both objects have the same number of protons, sorry, the same number of electrons. It is uh, it is now be called that the voltage is the same. It's not like that. It is not always like that. Okay. Even though there are many electrons on the other object, and then the other object will have a couple of electrons, but their voltage is the same, electrons between these objects will stop moving. Okay. And then, if we will separate now the two objects, once separated, both materials, uh, look at the pictures there. Both materials ended to have the same charge. Remember, our ruler has many electrons, and then it does not transfer all or half or all of its electrons to the rabbit fur. Okay, they just they need a couple of numbers of electrons in order to meet the equilibrium, or the voltage will become the same. That's the goal in conduction. Okay, both materials ended up to have the same charge. So once they are separated, look at the previous charge of our charged object. It's negatively charged, full of electrons. But then again, some of the electrons transferred to the neutral object. So what will going to happen? It becomes less negatively charged, but still it's negatively charged. It's just that some of its electrons transferred to the neutral object earlier to rub it fur. And now, what will happen to the neutral object since it accepts some electrons from the plastic ruler? It gains electrons. There is an additional electron. So the neutral object becomes negatively charged object because there's an additional number of electrons, making it more negative than before. From neutral, it becomes negatively charged. So if you look at it, one becomes less negative from more number of negatively charged, and then from neutral, it becomes negative. It ended with the same charge. Please take note. Okay, from neutral, um, zero charge, it becomes charged. It becomes negatively charged. So there's charging there. And that's what happened. That's what happened when you charge an object via conduction. Now, charging method. What is common between triboelectric and conduction? And what is uncommon between triboelectric and conduction? After watching and understanding the video, I want you to come up with your own idea. What's the difference between triboelectric and conduction, or friction, or charging by friction, or charging by conduction? What's their common, what's what's the common denominator of this? And then what is also uncommon between the two types of charging? Triboelectric charging, contact charging, or conduction? Let me know. You can put your answers on the comment section. Okay. I have maybe one more example. Okay, my slide is like shuffled at some point. I have it here. My previous example, I have a negatively charged plastic ruler, but this time we'll have the positively charged rod, meaning many protons, many positives. It contains few, few electrons because it's a positively charged, more positive. And we will touch it to a neutral metal. Neutral metal means it has the same number of electrons and protons as you can see there. Okay, that's a neutral metal. Same number of protons and electrons. The goal is to touch the positively charged to the neutral metal. And we will go back to the definition of conduction when a charged object touches a neutral one. So these are our two objects needed for conduction to happen. All right, we will touch it directly. There's a contact. Of course, it's contact electrification, so contact is needed, direct contact. So what will happen upon contact via conduction when a positively charged object touches a neutral metal? What will happen? Take note, electrons are mobile. They keep on moving, or diffused or moving around the nucleus, and the protons are immobile or stagnant. They're not moving. So for sure, or logically speaking, the protons or the positive will not be the one moving and transferring to another material. It's the electrons. It creates electron potential difference or voltage because we have different concentrations of electrons in both materials or objects, so it creates a voltage. Now the electrons from the neutral material or from the neutral metal will now transfer to the positively uh, charged rod. Why? Because the positively charged rod will have many electrons and many protons, but few electrons. Remember, electrons transit, it will move from high to low. So the neutral metal contains high electrons, although the image doesn't say so. But in that case, since it labeled the charged rod is having few electrons, so therefore the neutral metal have more electrons than the positively charged rod. So again, since in neutral atom, it has sorry for the term. In neutral metal, it has many electrons than, or it has more electrons than the positively charged rod, since it's a positively charged one. So it contains few electrons. Electrons will move from high concentration to low concentration. So from neutral metal, it will move to the positively charged with low number of electrons. Or if we focus on voltage, when you have more electrons, the voltage will drop or it will have low voltage. If you have few electrons, the voltage there will become higher. Therefore, it will move from low voltage to high voltage. It's the same thing. Please remember that concept again and again. So electrons move from sphere metal to rod due to electron concentration or voltage. Depends upon what concept you will use when you explain the motion or the transfer of electrons from one object to another. In this case, it's not the electrons from the positively charged transfer to the neutral metal because it does not follow the rule. Electrons flow from low voltage or high concentration of electrons to high voltage or low concentration of electrons. And upon separation, when we separated these two materials, what will gonna happen? Both materials will end up same charge, not negatively charged, but it must be positively charged since positively charged touches the neutral one. Just like our previous example, negatively charged object, ruler touches the fur, and then not fur, okay, touches another object, okay, and then since we use the negatively charged ruler after conduction, when we separated them, two object becomes negatively charged. In this case, we use positively charged object. It touches the neutral metal, and once separated, this is what will happen. Both will become positive. Okay, the rod is now becoming less charged, less positively charged because there was an additional electrons from the neutral metal going to our positively charged rod. So it has now electrons coming from the neutral metal, so it becomes positively charged rod, but it's lesser now compared to the original rod or the initial rod that we have. Okay. Now, since the neutral metal lost its electron, some of its electron, so this neutral metal will have more positive than negative because the negative charge is being transferred to the rod. So imagine When that happens, there is now a decreased number in electron. So the positive or protons will have more number. From the same number, electrons are transferred. So now protons stayed there. So now it becomes positively charged, more proton than electron. So if you notice, positively charged, but it's lesser because of the additional electrons from the metal sphere. And the sphere from neutral, it becomes positively charged. So it ended up with the same charges once you separate them via conduction.
So today we will have to know the north stars of our contact charging or conduction. I want you to come up with an idea. What's the materials needed when you want to charge it by contact charging or conduction? The answer is one material must be a charged material, negatively charged or positively charged, and paired or touched with a neutral one. So again, charge one and a neutral one. That's the materials needed to start contact charging or charging by conduction. Now, the motion of electrons due to electrical potential difference or voltage that pushes electrons. Okay, it depends upon your concept or your point of view. Not point of view, but the basis. In terms of electron concentration, the electrons will move from high concentration of electrons to low concentration of electrons. That's the transit for electrons to transfer because of the voltage, the force that push these electrons. If you were going to use the basis of electric potential difference or the voltage itself, when there will be high concentration of electrons, the voltage is low. And then if there will be low concentration of electrons, the voltage is high. So it will move from low to high voltage. The result, both materials will have the same charges. Again, it could be both have positive charges depending on what particular charge material you introduce. If you introduce a positively charged object, the result, the neutral object will become positively charged. If you will introduce a negatively charged one to a neutral object, the neutral object will later become negatively charged. Okay?
Okay, so that's it for this video. I hope you learned something about conduction or charging by conduction or contact charging. It is another type of contact electrification together with triboelectric charging. And the questions a while ago, what's the difference or what is common or uncommon between these two types of charges? Let me know. You can participate on the comment section. Okay. Thank you so much for watching, and I hope you learned something. See you on our next video. Bye for now.